Okay, this is the second of two videos in Math 31, section 8.3, and the subject here is area, volume, and surface area. And we've done two-dimensional objects in the previous video, and now we're switching to three-dimensional objects. The first of these objects is a rectangular solid, otherwise known as a box. And the formula for the volume is really simple. It's just multiply the three dimensions, length, width, and height. So if you do that, you take your length of 22 times your width of 10 and your height of 12, and that comes out to 2,640. And now we have volume units, which are cubic. So cubic meters. A cubic meter would be like a box. It's 1 meter wide, 1 meter tall, and 1 meter long. And it's actually quite a bit of volume. It'd be like one of those really big trash cans that you put up on the street. Okay, the surface area is the area represented by, hang on, let me get some good highlighter color here. It's the area of the front surface, its partner, the back surface, the top surface, and its matching bottom surface area, and the right side and the left side. So there's 6 sides, and you're just figuring out what the area on the surface of those sides are. The first one that's shown here is 2 times length times height. And so the length, 22, times the height, 12, would be the area of this rectangle that we would call the front. And because there's a back of the same size, you simply multiply by 2. Well, you do that with the other pairs also. And so all we need to know is length, width, and height here, and we'll put it into the formula. So you can see here, I'll just go through it one at a time here. I have 2 times the length times the height, then plus 2 times the width times the height, and then finally 2 times the length times the width. So you're just plugging into this formula here and do the calculations. Multiplication happens first, then addition happens next, and you get an area of 1,208 square meters around the outside surfaces of that box. Please notice that the area here is in square units, so square meters in this case. So areas in square meters, volumes in cubic meters, and we're doing both sorts here. Okay, the next one to look at is a cube, and a cube has a volume of side length to the third power, or side length cubed. We actually name that third power cubed because of this type of problem. So you're going to take the side length of 4.5 inches on this cube, and you actually cube it. 4.5 times 4.5 times 4.5, and that gives 91 and an eighth, or 91.125 cubic inches. That's how much it would hold inside the box. Now the surface area, you're going to take the front shape, which is a square, and find its area. And then since all 6 surfaces are identical, top, bottom, left, right, front, back, you just multiply by 6. So let's see how that looks like. You have to do the squaring first. So 4.5 times 4.5 to get to 20.25. And then multiply by 6 to finish it off. Okay, a sphere has a more complicated formula, but it only uses one piece of information. The radius is all you need to know to find the volume and the surface area both. They have different formulas. The amount of inside volume, how much it holds, the capacity of this ball or sphere, is 4/3 times pi times the radius cubed. So we plug all the numbers in, and I've tried to do it here like you would type it on your calculator. 4 divided by 3 inside parentheses, that's how you type the 4/3. We're using an estimate in this book of 3.14 for pi. And then you're going to do 5 to the third power, that's the r cubed. Now the cubing happens first, so 5 times 5 times 5, then times the other numbers. But honestly, if you just multiply the whole thing all at once on your calculator, it'll take care of the order of operations. So it knows, for instance, to do the cubing first. The divide key is how you get that little forward slash behind the 4. So you say parentheses 4 divided by 3 parentheses. That's how you get the 4/3 in. Okay, the next one has actually an easier formula. It's 4 times pi r squared, and it's beyond the scope of this book how they get this formula. However, it's very easy to use the formula. You just put in the information of the radius and what pi is, or at least an estimate. Now, we are estimating, so in the end, these answers are both estimates, and you want to indicate that with putting a dot with the equal sign. And the reason they're estimates is that value there, 3.14, is not actually the value of pi. It's an estimate of pi. The next shape we're going to look at is a cylinder, and I'm giving you the formulas in this section here. The cylinder has a volume of pi r squared times the height. So we're going to plug those numbers in. The radius of this one is 8.3, and the height is 25.2. So here is, in order, pi r squared h, and you multiply it out, and then make sure that when you're talking about volume, use the cubic version of the unit. So these aren't meters or square meters, they're cubic meters because it's volume. Okay, the next one here is a more complicated formula. It's 2 pi r squared plus 2 pi r. Now, all I'm going to do is explain the last half here. Pi r squared, you learned earlier in the course, is, well, actually in these notes, is a formula that tells you the area of a circle. Well, this one has two circles. The top is a circle, and the bottom is a circle, so that's why there's two of those areas. And the rest of it here is called the lateral area, and it's the area of the label that goes around the can, if you want to just use a mundane example. So it's the area of the outside part of that cylinder. So all we have to do here is plug in the numbers. So you put in 2 pi r, the radius, times the height, and then plus 2 pi, the radius, squared. And type all this on your calculator. It'll do the order of operations for you. In other words, it knows to square first and then to multiply and finally to add. So in the end, you end up with 1,746.154, and that'd be the surface area around the outside of that can. Now, it's an estimate, so we'll put a dot there. And the reason it's an estimate or an approximation is because we don't have the exact value of pi written down. And pi, by the way, has to be either written symbolically or it has to be estimated in a decimal format. You can also do 22/7, which is close, but pi, if you're going to do it exact, has to just be left as the symbol, the Greek symbol pi. Okay, the Greek letter pi. All right, the next one here is a cone, and it is pi r squared h divided by 3, or 1/3 of pi r squared h. So we'll plug these numbers in. Now I'm going to highlight something for you. The height of the cone goes from the apex down to the center of the base. That's the height of it. It is not that section over there, okay? So the height has to be perpendicular to the floor. And first of all, the volume. You plug the numbers in, and the first part here is going to be 1/3. You type parentheses 1 divided by 3. Then you're going to use the estimate of 3.14 for pi. Then you're going to put the radius and square it. And then you're going to multiply by the height. And that gives you an answer of approximately 527.52. The units here in volume would be cubic feet. Cubic foot is fairly easy to visualize. If you're an American, you have an idea of what a foot looks like. Just picture a block that's 1 foot wide, 1 foot long, and 1 foot high. And maybe a small trash can would be about that volume. Okay, the formula for the surface area is more complicated, and so I'm just going to uncover it here and talk you through it. All right, you're supposed to take pi, and that'd be there, and then the radius, and that's that radius down there. And then the rest of this here is finding what's called the slant height. And you don't have to worry about it. Just put what's there, square root of r squared plus 14 squared. And then plus pi r squared. So just type it all, write it all down first, and then you'll type it in just like it looks like. Now I'm going to tell you where the priorities are here. And if you're calculating this one step at a time, what you have to do. You have to first of all do the parentheses first here. Oops, I'm having a little trouble here. You do the stuff inside that that square root. Then you do the square root. You'll do this next. You'll do all the multiplications, and then the last part is the addition. Well, that's a little hard to get through, so my suggestion is you type exactly what you see there, just type it all at once, and let your calculator figure out the order of operations. So that turns out to be that turns out to be what looks like exactly 400 square feet, but remember, when you're estimating pi, your answer can't be exact. Okay, the last one is a pyramid, a square pyramid here, and it's more complicated. The volume's not so bad, it's the surface area that's more difficult. So I'm just going to do the volume really quickly here. You take 1/3, and you'll type on your calculator 1 divided by 3 with the parentheses around it. And then your side length, and this one, in this case, is 10, and times the height, and the height is marked as 18. So here's your 1/3, your side length squared, your height 18, and that turns out to be very close to 600 cubic centimeters. A cubic centimeter is a volume that would be similar to the old style sugar cubes, real small. Okay, the surface area has a major difficulty. Two things, actually. One is that the big B stands for the area of the base. So let me draw what the base of this thing looks like. It's a square. It's 10 by 10. And that base has an area of 100. So where that B is, I'm going to put 10 by 10 would be 100 square centimeters in this case. Then the rest of it is a half times a perimeter times a slant height. And the slant height is the more difficult part of this, finding that. Now I'm going to show you, first of all, the height. There's the height. And the slant height goes down the side over to there. And then we've got this little segment down there. And together it makes a right triangle. So I'm going to label that L there. And we're going to calculate it. Let me draw it off to the side here. It's 18 on this side. We don't know what L is. And the other segment is 5, and that would be from the center of the floor to the edge. So it's 5. Now, if you do Pythagoras, you'll be able to figure this out here. So L squared equals 5 squared plus 18 squared. So then L squared here is equal to 25 plus, oh gee, I'm on the spot here, 18 times 18. 64. So 80 and 6 more. 80 and 60 more is 144. So is that right? 64, 8 and 6 is 14. Okay. And then we get 0 and a 1, 8. So this is 324. And then we take the square root of that to get the slant height. So let me write this down here. Plus 324. Oh, not yet. We don't take the square root yet. 324. And then L squared would be, add those together, 349. And let me uncover this here and see what I've got on this thing here. I had this all written out. Hang tight and I'll clear that up for you. So here's the calculations. Give me a second. I'm obviously blowing it here. Okay, so let me erase that. And I'm not going to be able to untangle that, but it's 18 squared plus 5 squared is 349, and then you take the square root to get 18.69. Okay, so you can see I put that in for the slant height there, and you end up with a surface area of 473.6. So maybe I should just, let me just write this out a little more clearly here. I'll do it again here. L squared, this is Pythagoras. So that's L squared is 25 plus 324. So L squared is 349. And then we simply take the square root of both sides. And that turns out to be the 18.68 that you see on the in the diagram over there. Okay, so that does it for us for the second half of the 8.3 notes.